Published in the last year of his life, Copernicus truly decided to leave this world with a loud bang. His book would challenge over 1,000 years of established knowledge and signal the beginning of the modern scientific revolution. Copernicus, on the revolutions of the heavenly spheres. The editor and original publisher wrote a very significant poem to start the astronomer's work. Let me quote of it.
Diligent reader, in this work, you have the motions of the fixed stars and planets, embellished by new and marvelous hypotheses. Let no one untrained in geometry enter here.
I love the last line. It surely aims to recall the line at the entrance to Plato's Academy. As such, the publisher, Andreas Ojender, is aiming to connect Copernicus' revolutionary hypothesis with ancient and traditional wisdom. The editor also attempts using skepticism to protect the writing. Skepticism is needed for any real philosophy, and so he says,
So far as hypotheses are concerned, let no one expect anything certain from astronomy.
Skipping ahead, in his own foreword, without yet providing any argument, the author starts by defending his possibly blasphemous position. As such, his writing is directed towards none other than Pope Paul III. He admits to the Pope that he was ever uncertain about publishing his opinions. Yet, he explains he was motivated by several clergymen. But what motivated him to question the pre-established knowledge? Let me quote.
I was impelled to consider a different system of deducing the motions of the universe's spheres for no other reason than the realization that astronomers do not agree among themselves in their investigations of this subject.
He describes his contemporaries as having various pieces, but unable to fit them together to describe a coherent whole. The believers of geocentricism are forced to invent new hypotheses which do not accord with other elements in their model. Copernicus' model, he claims, fits everything that is already agreed upon, such as the size of the planets and their distances to Earth, without having to introduce superfluous or contradictory hypotheses. The astronomer then mentions how he found from Cicero and Plutarch that certain ancient philosophers argued in favor of heliocentrism. He quotes the latter, who in turn credits the Pythagoreans. In fact, it seems that Copernicus might have been a secret Pythagorean. More about that later. I should make clear that all through the first half of his book, he repeatedly returns to defending himself against possible critics. For example, he insults a certain Lactantius for being ignorant of astronomy and nonetheless willing to make claims about the cosmos. In the first chapter, the introduction, the astronomer first eulogizes the value of his profession. Consider the lines.
If then the value of the arts is judged by the subject matter which they treat, that art will be by far the foremost which is labeled astronomy.
It surprises me how most of his claims are based on the observations gathered by Claudius Ptolemy of Alexandria, the Greek philosopher of the 2nd century. Meaning, Copernicus speaks almost as if whatever Ptolemy observed is the one and only trustworthy data. Of it, the only issue is the way the data is interpreted. Of course, interpreting the data is arguably the main challenge in any inquiry, LOL. Although the prior is perfectly philosophically sound, the subsequent is silly. Copernicus holds that the universe and the celestial bodies must be round because,
of all forms, the sphere is the most perfect. All the separate parts of the universe, I mean the sun, moon, planets, and stars, are seen to be of this shape. Hence, no one will question the attribution of this form to the divine bodies.
Yes, planets are round, but that is not a cause of existence. That is merely an effect of other forces. Either way, apparently some did need to learn the prior, as Copernicus then provides a myriad of proofs that the Earth is round. For example, which stars are visible depends on the hemisphere. If Earth were flat, then all would see the same stars. Likewise, eclipses are not seen by all. Also, how retreating ships progressively sink beneath the horizon. Or how about the shadow that Earth casts on the moon? Those kinds of proofs were known since ancient times. Skipping a bit, Copernicus explains the relative nature of seeming movement.
Every observed change of place is caused by a motion of either the observed object or the observer, or, of course, by an unequal displacement of each. For when things move with equal speed in the same direction, the motion is not perceived.
Also, he quotes Virgil's Aeneid, which you may also learn about on this channel. He provides the lines.
Forth from the harbor we sail, and the land and the cities slip backward.
Meaning, do not trust your eyes. It may seem that the others are moving, but perhaps it is you that moves. As this may seem uncommonsensical, the astronomer flips the charge and questions whether common sense would have that the huge universe moves, while the little Earth stands still. Once again, he credits Pythagorean philosophy for such an insight. To justify the prior, the Renaissance thinker must show that the universe is immense compared to Earth. This is the only way to explain why, if the Earth moves around the Sun, the stars are not seen shifting their position. Meaning, the stars are so far away that the relative movement is imperceptible. To illustrate this hypothesis, he refers to Democritus' idea of atoms. Meaning, just as we cannot see the atoms because of our relative huge size difference, so too we cannot see the shift in the stars because of our relatively small movement. Continuing to dismantle the pre-established interpretations, he indicates,
The fact that the same planets are observed nearer to the Earth and farther away necessarily proves that the center of the Earth is not the center of their circles.
Yes, in geocentrism, the changing distances of the planets is explained by assuming that planets do not have perfect circular movements. If it were heliocentric, Copernicus believes, then there would be no need to distort the natural perfect form. Eventually, Copernicus must deal directly against Ptolemy. The ancient philosopher said that the Earth moving would require great force and therefore destruction. The clouds would be stripped from the atmosphere, the water would spill out, the Earth would crumble. Copernicus replies the following.
If anyone believes that the Earth rotates, surely he will hold that its motion is natural, not violent. Ptolemy has no cause, then, to fear that the Earth and everything earthly will be disrupted by a rotation.
It is funny as this reply amounts to saying that it works because that is the way God made it. Yet, perhaps unfortunately, many ideas in science end up in a similar manner. Like subatomic randomness or atom decay, the answer often is, that is their nature, LOL. More logically sound is the retort that Ptolemy should be worried that the upward pressure of air and fire would expand the universe infinitely. Of course, given the increasingly expanding universe and dark energy, such a retort is jocular to a modern audience. The Renaissance thinker also argues that perhaps mere proximity to Earth grants air and fire certain earthy qualities. He takes this possibility so far that he even hints at a theory of gravity. Consider the lines.
I believe that gravity is nothing but a certain natural desire. This impulse is present, we may suppose, also in the Sun, the Moon, and the other brilliant planets.
That is worthy of awe. Willing to take on double opponents, Copernicus also challenges Aristotle himself. The renowned philosopher argued that inanimate bodies only move in three possible directions: either up, down, or circular. I should clarify that by up or down was meant to or away from the center of the Earth. As such, Earth and water tend to move down, while air and fire move up. Copernicus says that existence has greater nuance. Surprisingly, he is aware that falling bodies do not fall at constant speeds. Likewise, rising air or fire does not rise evenly or constantly. Instead, he points out their movement tempers. Thus, whether they move linearly or circularly depends more on position than on their composition. Therefore, he has it that objects in space move circularly, while objects near Earth move up or down. Brilliant. Let me quote.
Surely Aristotle's division of simple motion into three types will be construed merely as a logical exercise. In like manner, we distinguish line, point, and surface, even though one cannot exist without another, and none of them without body.
That is so jocular, I wonder if he meant it as a bit of a slap in the face? Noteworthy is the argument that immobility is divine, and therefore should be attributed to the home that divinity created for humans. He responds that the divine quality is more fit for the cosmos as a whole. Geocentrism requires that the whole of God's creation be robbed of the divine quality of stillness, while in heliocentrism,
In the middle of everything is the sun. For in this most beautiful temple, who would place this lamp in another or better position than that from which it can light up the whole thing at the same time. Thus, indeed, as though seated on a royal throne, the sun governs the family of planets revolving around it.
Yes, yes, that was also a Pythagorean imagery. After all the prior, to legitimize his idea, the astronomer must describe in detail what the cosmos actually looks like. This begins with estimating the distances to the various celestial bodies. He follows the classic assumption that the longer time it takes the planet to complete its cycle, the farther it must be from the center of the rotation. As such, he is correct in how he orders the planets of the solar system. Although he has no knowledge of Neptune and Uranus and Pluto, there is a big debate over Mercury and Venus, as the geocentric view was not clear on whether they were closer or farther than the sun. Likewise, their movements were seemingly erratic. Copernicus is sure that they must be closer. He spends quite some time proving it, but I will skip over it. Simply let it be known that in this debate he references certain Islamic Arab astronomers. Copernicus must also invent the idea of a tilted Earth. Amazingly, it truly is me, he recognizes that the observations of the movements of the celestial bodies require the Earth's own gyration be tilted relative to its rotation around the sun. Since this is presently popular knowledge, I will skip his explanation. Instead, I consider more noteworthy his desire to quote a Pythagorean letter, a rare Pythagorean writing. The Renaissance thinker has already referenced the possible danger in disseminating knowledge to untrained, uncultured, vicious minds. Avoiding such a thing was a foundational element of Pythagorean philosophy. The letter which Copernicus himself translated from Greek to Latin concerns this same issue. It speaks of the natural viciousness found in human beings and the necessity, therefore, of proper upbringing. Copernicus initially intended to publish this, but in the end did not. The letter was only included in editions published well after his death. I think it speaks of the kind of person he must have been, his own personal philosophy. Regardless, the subsequent portions of his book are very mathematical and geometrical. The Renaissance astronomer must detail his entire model of the cosmos. This involves calculating relative distances by way of comparing the apparent positions of the celestial bodies. To be brief, know that he ascribes a value of 1 to the distance between the Earth and Sun. Then, knowing the angle between an Earth-Sun line and an Earth-planet line, he calculates the relative distances. I will not explain it in greater detail. Instead, know that the value of 1, the distance between the Earth and Sun, is still the standard value of distances in astronomy. I should also note how a big issue concerns the fact that the planets do not rotate around the Sun in a flat plane. Their rotation around the Sun is slightly tilted relative to each other. I find it curious that given his insistence on perfect or ideal forms, he does not see any issue with this reality. Of course, the geocentric view would have this same problem. Alas, I would say.
Since it defies our sense of order and does not offer much hospitality, surely the universe was not made for us.
Better to struggle in an indifferent world than to fail in an allegedly divinely crafted home.
Since I just gave you 2 aphorisms, in this case simply know that this is the beginning of a series on Renaissance natural philosophers. Aside from Copernicus, it will include works by Giordano Bruno, Galileo Galilei, Johannes Kepler, and Francis Bacon.